This video is about surface area and volume of 3D solids. Let's go to 6a. TBs were traditionally used by nomadic tribes who lived on the Great Plains of North America. They are cone-shaped dwellings and can be modeled as a cone with a vertex 0, shown below. The cone has radius r, height h, and slant height l. A model TP is displayed at a Great Plains exhibition. The curved surface area of this TB is covered by a piece of canvas that is 39.27 meters squared and has a shape of a semicircle. As shown in the following diagram, show that the slant height L is 5 meters, correct to the nearest meter. According to the given information, this is a semicircle, which means the area equals 1/2 pi r squared. Because for the circle area is pi r squared, semicircle means 1/2 pi r squared. Remember, this r is not this r, it's different. What's the radius for this semicircle? It will be L. In other words, for this formula, I can write down 1/2 pi L squared. So we get the area equals 1/2 pi L squared. And an area that's 39.27 equals 1/2 pi L squared. We need to isolate this L. So get rid of this 2, we multiply by 2 both sides. Get rid of this pi, we divide by pi. So L equals square root 2 times 39.27 over pi. L equals 5. You are encouraged to use equation solver to figure out this L. You will do 39.27 equals 1/2 pi L squared. Get the equal 0. So move everything to the left side, change sign. 39.27 minus 1/2 pi L squared equal to 0. Then you can get the L equals 5. Now we figure out this L equals 5. Let's go to 6b. Find the circumference of the base of the cone. We already figured out the slant height is 5, which means from here to here. But when you fold this semicircle from this 0, you will see the circumference of the base of the cone will be this, which means half of the circumference of this semicircle. Therefore, for this circumference equals, this is a formula, 2 pi L. You need to divide by 2. So we put into a graphing calculator, you will get 15.7. This L is 5. Basically, you can put the 5 pi. Then you can get the 15.7 meters. Now let's go to second one. Find the radius r of the base. We already know the circumference of the base of the cone. We can get this r. So we do 2 pi r equals 15.7. Then this r equals 15.7 divided by 2 pi. You will get 2.50. Now let's go to the third one. Find the height of h. For this right triangle, we use the Pythagorean theorem. We can get this h. For this h, this is a leg. So we can do L squared minus R squared, which means 5 squared minus 2.5 squared. We put into a graphing calculator, you will get 4.33 meters. Let's go to 6C. A company designs cone-shaped tents to resemble the traditional teepees. These cone-shaped tents come in a range of sizes such that the sum of the diameter and the height is equals to 9.33 meters. Write down an expression for the height h in terms of the radius r of these cone-shaped tents. Diameter and the heights, the sum equals 9.33 meters, which means 2r plus h equals 9.33. Therefore, for this h, you will do 9.33 minus 2r. So h equals 9.33 minus 2r. This will be the answer to this question. For 6D, show the volume of the tent V can be written as this formula. According to the volume of a cone, we use 1/3 pi r squared times the height. From this formula, we know that there is no h, so we need to plug in using 9.33 minus 2r to substitute this h. You will get 1/3 pi r squared times 9.33 minus 2r. So we do distributive property. You will get, check this formula. You could say there is a pi. So this pi leave as it is. Don't change into 3.14 this time. So we do 3.11 pi r squared minus 2/3 pi r to the third power after we did the distributive property. Then we finish this question. Show that we already show how we get this formula. For 6E, we need to figure out dV by dr. That's the derivative of ax to the nth power. This is the formula you got to use. Drop down n, then is get the n minus 1. Therefore, for dV by dr, since this is a polynomial function, I will do 3.11 pi r squared, we do derivative. Then minus 2/3 pi r to the third power, we do derivative. if coefficient stay, therefore 3.11 pi stay, r squared, you will get 2r2 minus 1, that is 2r. So multiply by 2r minus. Always take out the coefficient, 2 over 3 pi, you stay. R to the third power. Drop down the 3, that's 3 minus 1, that's 3r squared. Therefore, you will get 6.22 pi r minus, reduce this, 2 pi r squared. Let's go to 6F. Determine the exact value of R for which the volume is a maximum. If the volume is a maximum, then the derivative will be equals to 0. In other words, you will set up this equals to 0. 6.22 pi R minus 2 pi R squared equals to 0. You can use a equation solver or plug into Y1 and then graph. From the graph, you can figure out that zeros. First step, you need to clear the memory. So second plus 712. We need to put the function into Y1. That is 6.22 pi x minus 2 pi x squared. We need to figure out the 0. That means the x-intercept. So we graph first. For this graph, we need the x-intercept. We don't care about the maximum points. We just need an x-intercept. When it's 0, 0 is not the solution. So we do second trace, go to 2. Then move the arrow close to the left side of this 0. I put the enter. Then to the right side of this 0, put the enter. You will get 3.11. Another way is you go to equation solver. See math, equation solver. We will put the Y1, then enter. We think 10 will be our solution. So we do alpha, enter. You will get 3.11. There is another way to figure out the R if we want to make volume its a maximum. We don't deal with this derivative. We put in the function of volume. That is 3.11 pi x squared, that's r squared. Then minus 2 divided by 3 pi x to the third power. Then we go to graph. We need a maximum point. So we need to change this y maximum. Let's do 100. Here we do 10. Graph. we're looking for this maximum point now. So we do second trace, maximum, that's 4. Move the arrow close to this maximum point, enter. Then to the right side of this maximum point, enter, enter. You will get this R and also the maximum volume together. From graphing calculator, we will get the R equals 3.11. Find the maximum volume. For this R equals 3.11, you need to plug into this formula. So volume equals 3.11 pi 3.11 squared minus 2 over 3 pi 3.11 to the third power. You will get 31.5 meter cubed. I already show you on the graphing calculator how you get the maximum points from the graph. Remember, when you're working on the maximum point, use the original function. It's much easier. And also, you need to remember, when derivative equals 0, we can figure out the maximum or minimum point.